Hello, my name is Cooper Barth, and this is my end of quarter video for Fall 2019 DTR. Recent advances in mobile social computing have led to advances in the development of what's called physical crowdsourcing systems. These include both paid systems that coordinate workers to provide on-demand services, such as Uber, and volunteer-based systems that enable community members to flexibly and conveniently contribute to tasks, such as searching for lost items and scientific data collection. In order to increase participation in these volunteer-based systems, recent work in on-the-go crowdsourcing has explored ways to lower the effort of participation by eliciting contributions that seamlessly fit into people's existing routines. For example, in a food delivery application, if a potential helper passes by a Starbucks and gets a notification that someone near their destination is interested in getting coffee from that location, then they may contribute because they wouldn't have to go out of their way in order to do so. Existing work in these volunteer-based on-the-go systems has explored ways to utilize the current and future availability of potential helpers in order to manage routing and task notifications in a way that optimizes the allocation of contributors to where they are most needed. There is a gap in the research surrounding the needs and behaviors of requesters in peer-to-peer tasking services and how they impact the experiences of helpers and requesters alike. In directed systems such as Uber, requesters have a strong mental model of whether and when their requests will be completed because helpers are paid to complete tasks on demand. When you place a Postmates order, you know that you're going to get your order some point soon, between usually around 25 to 45 minutes, because you know that somebody has been notified and will be fulfilling that order. In on-the-go, however, requesters don't know whether or when their requests will be completed, because helpers only contribute when it's convenient for them to do so. Because of this, several problems arise. First and foremost, requesters may lose attention to the system or become engaged in other activities while waiting for their task to be accepted, and this can force the helper to wait or reroute in order to complete the task. Push notifications and direct communication mechanisms support attention once a request is in progress, but fail to scaffold a requester's understanding of whether and when a task will be accepted beforehand. If a system fails in this manner, helpers may become disincentivized from further use of the system. Secondly, a requester won't want to participate in the system if they're not confident that the value of their participation outweighs the value of them completing the task themselves, such as simply walking to the nearest Starbucks instead of waiting for somebody to maybe accept their order some point in the future. So our high-level approach to solving this problem and filling this gap in the research is to model contextual information about the uncertainty in potential helpers' availability and participation to help requesters reason about how their decisions impact their individual and community goals, and give them agency and flexibility to manage those goals. If we give requesters these conceptual levers that they can use in order to understand how their decisions to give up or retain flexibility while they're participating in on-the-go systems impacts the needs of themselves and others, then they'll be able to make more informed decisions as to how and when they should engage in the system in order to fulfill these needs. So in order to implement this and reduce the cost of coordination and increase the likelihood of task acceptance in peer-to-peer delivery systems, we introduced the mechanism of predictive feedback, which uses the information about the availabilities and activities of potential helpers to enable requesters to understand the interplay between their willingness to engage flexibly and the likelihood of their tasks being accepted, and give them the agency to interact with the system based on this information. For example, If a requester understands that there is a location 5 minutes from them that significantly increases the chance that their request will be accepted, they can make the decision to either stay put or deviate and extract more value from the system. This awareness not only helps requesters elicit value, but also helps them reason about how their engagement affects the dynamic between themselves and their potential helpers, both with regards to coordination and the likelihood that their task will be accepted. In order to realize this approach, I'm designing an interface through which requesters are able to see in advance how their willingness to deviate and the selection of their meeting point affects the likelihood of their task being fulfilled. As the requester experiments with placing different meeting points on the map while they are going to request an order, a value score of the participation will be displayed and changed, which basically displays the chance that a helper will come and be able to complete their order. The requester can then choose the meeting point based on this information, balancing how they're going to strike a balance between their deviation to reach a farther meeting point with the chance of their delivery being made. From an architecture perspective, users' routes and behaviors are utilized to paint a picture of the activities of potential helpers near locations where a meeting point might be placed. First, the location manager on the front end sends data about participants' location and movement as time-coordinate pairs to the database. Later, when a requester opens the application to place a request, the app sends a request for the value scores for locations in the immediate area of the requester. Location data is retrieved from the database and sent to the route manager, which packages the individual data points into common routines that occur weekly around the time of the request and nearby the requested location. The value model then uses these routes to determine an expected value for each point in the region surrounding the requested point. The UI can use these scores to plot areas of high value and how the likelihood of task acceptance increases or decreases as you move across the map. The work I did this quarter primarily concerned need fighting and developing my conceptual approach, and thus I did not run a study. Next quarter, I will be testing and refining my prototype to make sure that it is both functional and helps to achieve my expected outcomes. In a practical setting, there are two outcomes that I'm planning to measure. The first is that requesters, using this system, can build stronger conceptual models about task details much earlier in the delivery process. I will be collecting this through qualitative interviews and an in-app survey. The second is that the overall task acceptance rate within the system increases. As I mentioned earlier, if requesters select more meeting points that are closer to the regular predicted routines of potential helpers, then these helpers should be more likely to accept these requests and participate in the system. Going forward with the project next quarter, my focus is going to be developing and refining this system. At the start of the quarter, I will further revise my canvas and submit a URG application. I will then spend time building up the application and running smaller user tests to ensure both that it functions correctly and that the outcomes I detailed for requesters are being reached in a controlled setting. I will then plan to run a study with the application with around 20 to 30 people, either at the end of next quarter or at the beginning of spring. So takeaways, the work that I did this quarter enables a broader approach to peer-to-peer tasking systems in which the collaborative aspect between people and the systems they interact with is emphasized. In traditional delivery systems, the system itself dictates where its participants should go and how they should be interacting with the system at all times. Through giving people agency to choose how they want to engage with the system and helping them make more informed decisions about how to do so, we can help people work with uncertainty in on-the-go systems to build their understanding of how they should participate in order to reach both their goals and the goals of others. This concludes my end of quarter video. Thank you so much, and I'll see you next quarter.